Kia ora Year 12. This is a really good complex numbers question from the March 2020 paper, and it's come up in a few old A-level papers. It's a really important pattern type, especially if you're targeting getting an A or an A star, and it uses geometry rather than coordinate geometry. So the first bit is a really easy 2-marker. And then the second bit is only 2 marks. If any of you have got a smarter way to do it than my way, please let us all know. Leave a note on Google Classroom. I've made up an extra question in this pattern type at the end because I want you getting to the point where you find this a really easy question. So the first part asks us to just sketch a locus representing the complex numbers z that satisfy this. So you should at this point be looking at that and going, okay, that's a circle with radius 1, and I can see where the centre is. So let's just start by doing that. So what have we got? Well, we've got z minus, what was it? Z minus 2 minus 3i is equal to 1. I'm going to rewrite that as z minus 2 plus 3i in brackets equals 1. So we know that's going to be a circle. The radius is 1. And the centre is going to be at 2, 3 if we write that in coordinate form. Now, you need to take a ruler into the exam so you can draw this yourself, and it's not too hard to do that, but I've used GeoGebra to do a nice version of it. So that's what my circle should look like here, and I've started doing the next part of the question as well. But you can see there's a nice circle, radius is 1, right? And so the radius is 1 tells me put the centre on and then draw on these points here, and then do a good freehand or with compass if you want to, circle. So that's fine. Now let's go back and look at the second bit. We have to figure out the least value of arc z for points on this locus. So remember that arc z means what is the angle that's being made by the positive direction of the x-axis with any point on that circle. So if we start off, you might not see straight away that it's going to be where the tangent, where the line between the origin and the locus forms a tangent, but it will, right? Because we want the lowest value. So if, for example, I'm looking out here, you can see that here, arc z is going to be bigger than it has to be, right? So we've moved that ruler around, and we can see that the lowest possible value will be where it forms a tangent. And for me, the key to seeing what to do in this question was remembering that the tangent is perpendicular to the radius, and that gives us one right angle triangle to start things off, and that's always useful. So let's draw in that right angle triangle. So we'll take the ruler. We don't have to find the coordinates of this point, and that's important to figure out, but we don't need that. So we've got that, and then we can draw in the centre to the origin. So that's one right angle triangle. It seems like a good place to start. What I'm looking for though is this angle in here, and I'm going to call that angle, which way around have I done this? I think I'm going to call this angle alpha. Now there are two other angles that we're going to figure out. We're going to get this angle in here, which is beta, and then I know the coordinates of this point, right? This is the centre, and it has coordinates 2, 3, and I've marked in point D down here. And this is going to give me a second right angle triangle. And then I'm going to use some year 10 trig to figure out this whole angle in here. Okay, so I've done that nicely in GeoGebra on the next slide, and this is what it looks like before we start doing any maths. Okay, let's just see if I can squeeze that in. So here we go. Now, I've put the answer on that screen. So the final answer is going to be 40.2 degrees. And we get it as follows. We're going to start by finding this, and then we're going to find this whole thing here, and we're going to get the difference between those two numbers. So let's start drawing some bad right angle triangles. This is my first one. Now, we know, what do we know? Well, we know that this side here is the radius, right? So we know that that has a distance of 1. And we know the coordinates of the centre are 2, 3. So just cleaning all of this up a bit, that means that I've got one side having a distance of 1, and I can use Pythagoras to get this distance. So this distance will be the square root of 2 squared plus 3 squared, and that works out to be root 13. So this is root 13. This side is 1 because it's a radius, and this angle, which I think we called alpha, where is it? It's gone. Let's call it alpha now anyway. So what's alpha? Well, I've got the opposite in the hypotenuse, so we've got sine alpha is equal to 1 over root 13. So alpha is equal to the angle whose sine is 1 over root 13, and that gives me alpha equals what? 16.1 degrees. And now we can do something similar, but using tan on the big triangle. Okay, so my big triangle, I'm going to find this angle now. So very badly drawn triangle. Here's my centre here. This side is 2, this side is 3, and we'll call this beta. So tan of beta is equal to 3 over 2. Beta is equal to inverse tan of that, and that works out to be 56.3 degrees. So what do I need to find in the end? Well, it's the difference between those two things. So we've got alpha here, beta here, and this whole thing is, whoops, sorry, that whole thing there was beta. So arg z is equal to beta minus alpha, which is 56.3 degrees. Sorry for the background singing, it's not me. And that gives me my final answer of 40.2 degrees. Okay, so it's actually a really simple problem, but you've got to see the geometry. So here's one more for you to practice. Let's do the same thing. So we've got this locus of points, z minus 7 minus 4i is equal to 2. And I want you to find the least value of arg z. Okay, so I'm going to leave that one for you to work through, but the final answer that you should get should be 15.4 degrees. Whoops, where are we? So arg z is equal to 15.4 degrees, and the two triangles that you should end up with for this question look like this. The small one with the radius in it is not this one. Let's see, the small one with the radius has got 2 here. This is the origin here. This distance should be root 65. And then on the big one, we've got 4 and 7. So theta works out to be 29.7. And what did I call this? Alpha worked out to be something very little, 14.4 degrees. And we've got a tiny bit of rounding going bad in there, but my final answer that I got was 15.4 degrees. So please, if you're in 13 MCA 2020, make sure that you can do these questions and email me if you need even more practice on them, and I can make you up some more questions. Thanks for watching. Got a couple of requests lined up, one for Jamie for last year's level 3 calc exam and Ethan's complex numbers one. I'll try and get those done tomorrow.